All right, guys, welcome to Unit 8B. This is going to be day one. We're going to be learning about sum and difference identities. These are the formulas you're going to be using for sum and difference identities. Some of them are when it's asking for cosine and when it's asking for sine. So let's just go ahead and jump into the first one. So the first example says to find the exact value of sine of 15 degrees. Now, typically we would find the y-intercept on wherever it is on the unit circle, and that would be our sine, but 15 degrees is not on the unit circle. 15 degrees is actually going to be halfway here. All right, so how do we find what the sine of 15 degrees is? Well, there's going to be several different ways to do it. But the first thing that you can think of is it's got to be, well, something that we have on the unit circle either added together to equal 30 or subtracted to equal 30. All right, so I have to pick two different values that either add together to 30 or subtract to 30. Now, or I'm sorry, 15, not 30. I don't have any two measures that I could add together to equal 15 degrees, but I do have two that I could subtract to equal 15 degrees. That's going to be 45 and 30. So we're going to be using this bottom right one here, sine of 45 minus 30, which is the same way of writing sine of 15. So then we'll write sine x, which is going to be the first one. So that's sine 45 times cosine of y, which is 30, minus cosine of 45 times sine of 30. Now we can use the x and y values that we know for 30 and 45 to find sine of 15 degrees. So sine of 45, if I go to the unit circle, I find 45 is going to be square root of 2 over 2 times cosine of 30, which is square root of 3 over 2, minus cosine of 45, which is square root of 2 over 2 again, times sine of 30, which is going to be 1/2. All right. Luckily, we're multiplying fractions here, so you can leave the numerators and denominators the same. We'll just multiply each by each other. So we have square root of 2 times the square root of 3. That's just going to be the square root of 6 over 2 times 2, which is 4, minus, we've got square root of 2 over 4. So just to combine this, we can't subtract the square roots from each other unless we want to use decimals. But if we're just going to leave it this way, we'll have square root of 6 minus the square root of 2 all over 4. And that is our answer. All right, so we're going to do another one the same way, except we're using cosine now, so it'll be one of the two left ones. And I feel like the radians are going to be just a little bit more difficult because we don't really think well in fractions. We are looking for a radian measure of 5 pi over 12. Now again, you're going to be finding two measures that you can either add together to be 5 pi over 12 or subtract to be 5 pi over 12. I'm going to go ahead and say that we're going to use pi over 4, which converts to 3 pi over 12. And if it helps for you to kind of like convert fractions on the side so you can kind of get a better visual of what to use, you can do that. If I were to use pi over 6, this would be 2 pi over 12. If I were to use pi over 3, this is the same as 4 pi over 12. So if I were going to use 4 pi over 12, I would have to use pi over 12, which I don't have. If I wanted to use 3 pi over 12, which I would have to use 2 pi over 12, because together they equal 5 pi over 12. And so that's what I'm going to end up using. So I am going to do, let's see, we've got cosine of x plus y. So cosine of pi over 4 plus pi over 6. All right, and we'll go ahead and plug in from here. So we have cosine of pi over 4 times cosine of pi over 6 minus sine of pi over 4 times sine of pi over 6. All right, so cosine at pi over 4 is square root of 2 over 2. Cosine at pi over 6 is square root of 3 over 2. Looks like we're using the same two locations. Minus sine of pi over 4. Sorry, I just like blanked for a second. And sine of pi over 6, which is 1/2. So yeah, we should end up getting the exact same answer because these are the same formulas, even though we're doing different things. So we have square root of 6 over 4 minus square root of 2 over 4. And again, we'll get square root of 6 minus the square root of 2 all over 4. All right, so now let's go to example number 3. An alternating current in amperes in a certain circuit can be found after t seconds using I equals 4 sine of 255 degrees times t. Rewrite using an identity and find the exact current after 1 second. So we're going to plug in 1 as t, but we have to find sine of 255 first. So in order to do that, we either need to subtract or add degrees together in order to find that. So I had said 225. I can use, again, you can use several different ones. You could use 210 and 45. You can use 225 and 30. I'm going to use 225 and 30 to add together. So sine of 225 plus 30 is equal to sine of 225 cosine of 30 plus cosine of 225 sine of 30. All right, sine of 225 is negative square root of 2 over 2. Cosine at 30 is square root of 3 over 2 plus negative square root of 2 over 2 again, and 1/2 here. So then we get negative square root of 6 over 4 plus negative square root of 2 over 4. So we get negative square root of 6. And you can write plus negative, or you can just write minus square root of 2 over 4. Again, very similar answer to the last one. All right, that we are going to verify that sine pi over 2 plus theta is equal to cosine. So let's see. One way we can find to verify that is if we are doing sine of pi over 2 plus theta, we will write that out as, I'm just going to rewrite it, pi over 2 plus theta. All right, is equal to sine pi over 2 cosine theta plus cosine of pi over 2. And again, I'm just using our sine identity up here. And then we have sine of theta. Okay, well, let's figure out what we do know. We can't really do anything with the thetas yet, but we can convert the sine and cosine of pi over 2. So sine of pi over 2 is 1. So we have 1 times cosine of theta plus cosine of pi over 2, which is 0, times sine of theta. And they're saying that this is equal to cosine of theta. Well, 0 times anything is just 0, and then 1 times it, whatever it's multiplying by is exactly the answer. So 1 times cosine of theta is just cosine of theta, and that is equal to cosine of theta. All right, so we're just using these identities to verify this information down here. All right, and the last one, so we have cosine of pi minus theta. So we're going to use this bottom left one here. Cosine of pi minus theta is equal to cosine of pi. Oh, hold on, let me turn my lamp on. All right, we've got cosine of pi. I'm going to move this up some. Times cosine of theta plus sine of pi times sine of theta. And this is supposedly going to be equal to negative cosine of theta. So let's convert what we have. Cosine of pi is going to be -1 times cosine of theta plus sine of pi, which is 0, times sine of theta is equal to negative cosine of theta. 0 times anything is 0. And this just becomes negative cosine theta is equal to negative cosine theta. Perfect. So the last thing I'm going to do is write down a couple of just fractions at the bottom of this page that are going to be helpful for you for the unit circle. Now, 2 pi over 12, 3 pi over 12. So I've just converted these to 12s, which I think will be helpful. This one up here is going to be 6 pi over 12. Then we have 8 pi over 12, 9 pi over 12, 10 pi over 12. Of course, all the way here is 12 pi over 12. Then we have 14 pi over 12. This is 15 pi over 12. And then we have 16, I'm going to write that up here, 16 pi over 12. This y-axis here is going to be 18 pi over 12. Right here, we've got, let's see, 20 pi over 12. The center here is going to be 21 pi over 12, and then we have 22 pi over 12. So hopefully these little fractions will help when you have to deal with the 12ths. All right, and that is the beginning of Unit 8B.